Okay. Okay. Hopefully now it gets stable, more stable. Um, yeah. So I repeat again. So when we want to find the coordinate of the COG or the centroid, yeah, then we, for example, here we want to first find the coordinate of the x coordinate, yeah, of the centroid. So here we calculate the moment about the axis y from each of the element, yeah, each of the surface element is within that plate. So here the formula is moment of the distributed forces equals to the moment of the resultant. So x1, this is the distance to element 1 within this plate, multiplied by the delta W1. Delta W1 is the weight of that small element 1, plus x2 delta W2, the element 2, etc., until xn Wn, yeah, equals to the centroid, or the coordinate of the centroid, or the center of gravity, multiplied to sigma W. Of course, here sigma W means the weight of the total weight of the plate. Okay, so mathematically it can be rewritten as sigma x upper bar, or sigma, which is the coordinate, the small x is the coordinate of each of the element in that plate, multiplied by delta W, the weight of the each of the element of that plate, the small element, equals to the x coordinate of the centroid or center of gravity multiplied to sigma W. And similarly, also if we want to find the y coordinate, means we uh, use moment about x-axis. Okay? So this is the formula now. The x upper bar equals to sigma small x upper bar delta W is divided by sigma delta W. Okay, so because this x, the centroid, times the total weight of that plate equals to the sum of the multiplication of the moment from each of the element in that plate. Sigma W here is the overall weight. Delta W is the weight of a single element. The small x upper bar is the center of gravity, or centroid if it is uniform, yeah, of the element x-axis, and y upper bar, small y upper bar, is the center of gravity of each of the element, the coordinate, yeah, from the y-axis. So the center of gravity about the y-axis also, or the coordinate y of the center of gravity, equals to the sigma y upper bar, small y upper bar, delta W divided by sigma delta W. However, how to calculate then the delta W? Since basically it is a volume, it's a plate having a uniform thickness. So delta W equals to the rho, the density of the plate, times the gravity acceleration, G, times the thickness, times delta A. Delta A here is the surface area of that small element. Okay, so if we put into the formula, okay, so let's say do again notation. So the x here will be equals to sigma x delta W divided by sigma delta W. Okay. So here this is equals to sigma x rho g t delta A divided by sigma delta A. Sorry, not sigma delta A, sigma rho g t delta A. Since rho is constant, the density across the plate is uniform. G is also constant. Let's assume that it is constant because it is limited surface area, not going across the whole Earth. The thickness also uniform. So we can put the factor rho G and T outside of the sigma summation factor. Okay. So this become rho G T sigma x delta A divided by rho gt sigma delta A. So here then this will cancel the upper part and the lower part. So this becomes sigma x small delta A divided by sigma delta A. Okay, sigma delta A is basically, so this is sigma x small delta A, and this is basically the total area of the plate. Okay, so similarly with the y coordinate, something like that. Okay. Then we give some example here. Determine the location centroid of the composite body, yeah, which has a uniform density as well as uniform thickness across all the area. So this is a geometrical shape. Basically, it consists of how many geometrical shape? If we define it like this, first it consists of this, number one, this one, number two, and number three. Okay, so this geometrical shape equals to 1 plus 2 minus 3. Okay, in terms of area, yeah, because the 3 is minus because it is a hole, so it is a void. It doesn't have any density, it doesn't have any mass. So from here, then we can calculate the centroid and center of gravity. First, we determine the axis, which is basically already established in the problem. Segregate into common shapes, as we have done earlier. So rectangular, triangle, and circle. Areas of holes must be subtracted. That's why we put a negative sign. Make sure the combination of the segregated parts will produce the original body. Then we calculate the area of each component. Then we determine the x and y coordinates of each component. Construct a table. Then we solve using the formula that we have studied in the previous slide. Okay. So here is the segregated shape. So the structure consists of three different basic shapes: rectangular, yeah, which has a length 0.6 meter and a height of 0.4 meter. So the centroid is in the middle, yeah, having coordinate 0.3, 0.2 meter. Second shape is a triangular, and the centroid is here 2/3, of course, yeah, 2/3 of the base, so it is at 0.4. Here the coordinate here is at 0.4 meter. Then this one is 1/3. Yeah, this one is 1/3 of this height. So it's 0.3, and it means 0.1. This one is 0.1, but this one is 0.4. So this coordinate is 0.5 meter. And this coordinate, yeah, this coordinate. Then the circle, the centroid or center of gravity is exactly at the middle, and it means it is at 0.3 and 0.4 coordinate. Okay, then afterwards we calculate the centroid and or center of gravity of each of the shape. Remember that for a hole, since it doesn't have any, it's subtracted, yeah, from the whole thing, then we have to assign negative sign. Delta A for the rectangular is length times height, 0.4 times 0.6, 0.24. The x coordinate of the centroid is 0.3, yeah, half of the length. The y coordinate is half of the height, 0.2. X, the coordinate times delta A, is 0.072. Yeah, this part is 0.3 times this part. Yeah, 0.3 times this part is 0.072 meter cubic. Y delta A equals to 0.2 times 0.24, 0.048 meter cubic. Second component is the triangle. So A is half of the height times the length. So half times 0.6 times 0.3, this one. So 0.3 times 0.3, 0.09 square meter. The x coordinate is 2/3 of the base length, so 0.4 meter. The y coordinate is 0.4, the base height, yeah, plus the 1/3 of the height of the triangle. So 0.4 plus 1, 0.5 meter. X small, the centroid, yeah, times delta A is this part. 0.4 times 0.09, we obtain 0.036 cubic meter. Y delta A is this part. 0.5 times 0.09 is 0.045 cubic meter. Then the third component is a square, a circular hole. So the area is negative pi square root negative pi times square of the radius. The radius is 0.1, so we obtain here negative 0.0314 square meter. The x is the middle, 0.3 meter. The y coordinate is 0.4 meter. And x times delta A is this times this one. So we obtain here. Y times delta A is this 0.4 times minus 0.0314. We obtain negative 0.01256. Then sum of the delta A, sigma delta A, is the sum of this type plus this negative this. We obtain 0.2986. The sum of x upper bar delta A is this part. Okay, so we obtain this 0.09838. The sum of y upper bar delta A is this part. We obtain 0.08044. So from here we can calculate the centroid or center of gravity of the whole structure. Sigma x upper bar delta A divided by sigma delta A. Here 0.09838. This one divided by 0.2986. We obtain the x upper, the new centroid, the center of the whole thing, the center of gravity of the whole thing is 0.329 meter. And for the y coordinate of that center of gravity is 0.08044, this part, y upper bar times delta A divided by sigma delta A, 0.2986. So we obtain 0.296 meter. Okay, so not difficult, right? So let's see if there are exercise at the last part. So let's go exercise here. Now, that is when the density is the same. In the second example, it consists of, it has similar geometry, yeah, consisting of a rectangular plus triangular, and then there is a hole, circular hole in the middle. But now it has some part of the rectangular has the density twice of the material of the other one. So here the density of material A, so from 0.2 meter above is twice the material at B, 0.2 meter below. Okay, so what should we do? So here we have to separate this whole structure, not only to become 3, but we have to separate it into 4 shapes, because now the rectangular also consists of 2 different material. One is of material A, the other one is from material B. So this whole structure is made from 4 segregated shapes. So here the step is the same. First is to determine the axis, segregate into common shapes. The areas of hole must be subtracted. Make sure the combination of segregated parts will produce the original body. Then we calculate the weight of each of the component, determining the x, y coordinates of each component. We construct a table. Then we solve using the formula as we have obtained earlier. Okay, so now the rectangular becomes 2 structures here. The first one, this is made of material A. yeah, whose base starts from the height of 0.2 meter until 0.4 meter. Second one is made from material B, okay, the material B, the bottom part, okay, from 0 until 0.2 meter. Then we have the triangular material and the circular hole. So then we make a table, then we draw here the component number, now 1, 2, 3, 4, the delta W of each of the member, the weight, then the x coordinate of the center of gravity of each of the component, the y coordinate of the component, then the multiplication of x times that delta W and multiplication of y upper bar to the delta W. So the first component is this one, the upper part. Here actually we do not really know, we do not need to really know the exact density later, since the correlation between density A and density B is given, which is density A is twice the density of B. So later we can put that into the calculation. So here at component 1, the delta W is the total the total area times the density, yeah, 0.12 times the rho A. So remember, if you pay some attention that in the previous example, we do not really care about the density. We do not put the density into the calculation because the density is homogeneous throughout the whole structure, yeah, in the first example. That's why then the density is cancelled between the numerator and denominator. However, in the second example, since now density is not homogeneous, we have to put that into the equation, into the calculation. So here we have the delta W cannot just be the area, but we have to put also multiplied with the density rho A. Here we assume that it is rho A, yeah, density of A. Then the coordinate is 0.3 meter, the y coordinate is 0.3 meter, then x times that delta W 0.036 rho A, y times delta W is 0.036 rho A as well. And then with component 2 is the triangle, similar like the previous example, only that here we put the rho A factor here. Okay, here. Component 3 is similar. Component 3 similar but different. Now it has different density, which is rho B, right? But we know the relationship with rho A, that is rho A is twice that of material B. So then here, after we express the delta W as the multiplication of the area times the density, okay, rho B, then we change the rho B into the rho A using that relationship that rho B is half of rho A. So this equals to 0.06 rho A. Then we do similar calculation as the above row. And with number 4 is also row A, so similar with example 1. After that, you obtain total delta W, we obtain total X upper bar delta W, total Y upper bar delta W. Yeah. Then we calculate the new centroid or new center of gravity here equals to sigma X upper bar delta W divided by sigma delta W. It's 0.338 meter, Y is 0.359 meter. If we compare the results with the previous example, example 1. In example 1, the X is 0.329 meter. Example 2, 0.338 meter. So it shifts a little bit to the right. Okay, why? Because here with the triangle, of course, then the right part is the material weight shifts towards the right part, right? Because material A is heavier than material B. And that is why the weight shifts a little bit to the right part. Then the y, in the first example, in the homogeneous material, the y is 0.269 meter. Since we now have the bottom material is lighter than the upper material, so we could expect that the y coordinate will shift upwards, right? The center of gravity of the whole structure will shift upward. And here we obtain y is also coordinate is increased to 0.359 meter from 0.269 meter, because now the upper part uh, material component is heavier than the lower part, because density of material A is twice that of material B. Okay, so this is the effect of having non-homogeneous density, yeah, in in, uh, in 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 the calculation. Yeah, so in the calculation of center of gravity, when you have different density, then your center of gravity will also shift. Okay, now let's have a look to the case of the centroid or center of gravity of lines. To determine the centroid and center of gravity of a homogeneous line with uniform cross-sectional area. So this is only a line structure without any area. So it has a, for example, it can be a rope or wire, the uniform cross-sectional area. So the calculation of the new center of gravity of the homogeneous line is similar to surface area, yeah, x1, which is we calculate the y coordinate based on the x coordinate from the moment about axis y and the y coordinate from the moment about axis x. So here my equals the x1 upper bar delta w1 until xn plus xn until xn delta wn, which is equals to x upper bar sigma w. Then sigma x upper bar delta w equals to x upper bar sigma w. So from here we obtain center of gravity about the x-axis equals to the sigma, the element, the each of the moment, yeah, of each of the element about the y-axis sigma, the sum, yeah, x of the moment, x upper bar times the delta w, and divided by the total mass, total weight of that rope. So then we obtain the new centroid or new center of gravity x coordinate. And similarly with the y coordinate, we obtain about the x-axis. So y coordinate equals to sigma y upper bar delta w, the moment of each of the element of that rope of that line, divided by the total weight of that line. Now in line or rope, the weight is the density times the gravity's acceleration times the cross-sectional area times the length of the line, or delta L, the length of the element. So if the line is homogeneous, then the rho, G, and A, the cross-sectional area, can go out of the sigma, the sum notation. Yeah, then they cancel between the numerator and denominator. Then the x, the new center of gravity x coordinate will be equals to sigma x upper bar of each of the element length element divided by sigma delta L. Similarly with the y coordinate equals to sigma y upper bar delta L divided by sigma delta L. So example is given here. Determine the location of centroid of the composite line here. So consisting of a vertical line, yeah, from negative 0.4 until 0, and the x coordinate is 0. Then a tilted line from O to B, yeah, from 0, 0, until here this is 0.3. The y coordinate is 0.4. Then there is a semicircular arc with a radius of 0.4. So here the center of the arc is 0.7 meter, yeah, 0.3 plus 0.4. The y coordinate is 0.4 meter. So determine the axis. In this case, is already established. Then segregate into common line elements, common line segments, which is we have discussed in the previous slide. Calculate the length delta L of each of the segment. Determine the XY coordinate of each of the component. Then we construct a table and then we solve using the formula x equal to sigma x upper bound delta L divided by sigma delta L. Y upper the new y coordinate of the centroid equals to sigma y upper bound delta L divided by sigma delta L. So this is the case now for the segment AO. The center of gravity is at the middle. Segment OB is also at the middle coordinate. While for the semicircular arc, the center of gravity is located here. Yeah? We have to look at the formula here. Later it will be given. So if we look for the common shape formula for line, yeah, for semicircular arc is this part, yeah, semicircular arc here. The center of gravity x-axis is at the middle, while the y-axis is located 2r over pi from the middle line. Okay, 2r over pi from the middle line. So coming back to our problem, example 3. Here, then delta L here from here is 0.4 meter. The x is at 0. The y is at this coordinate is negative 0.2 meter. X upper bar delta L here, x 0 times 0.4 is 0. Y times delta L is this times this one, negative 0.018. OB is this line. So the delta L will be calculated using Pythagoras theorem. 0. Square root of 0.4 square plus 0.3 square equals to 0.5. This is delta L. The x coordinate of the middle of the center of gravity is half of 0.3, which is 0.15. Y coordinate is half of 0.4, which is 0.2. Then we can easily obtain x over delta L and y upper bound delta L. Then the BC, the semicircular arc, delta L is from the formula of perimeter of a circular, pi times d, pi times r, pi times r, half of pi times diameter, or basically pi times r, which is equal to 1.25 meter. The x coordinate is half of this, which is 0.2 plus 0.3. Yeah, or wait, yeah, sorry, 0.4. Yeah, this is the radius is 0.4 plus 0.3, so it is 0.5, so 0.7 meter. Now y equals to this coordinate. Yeah, this is 0.4 negative this coordinate, which is negative 2 times the radius divided by pi. Okay, so this coordinate is this one is 2r divided by pi. Let's check again if it is correct. Here, yeah. Here, this from the middle part, middle line until that point is 2r divided by pi. So this is correct. So our example 3. Yeah, so 0.4 minus 2 times 0.4 divided by pi, okay, equals to 0.1453. So then from here, we can calculate x delta L, this times this one, 788, y delta L, this times this one, we obtain this. Then we sum this plus this plus this, we obtain this one. We add this time plus this, we obtain this part, and similarly with this column. Then finally, we obtain The new centroid, the new centroid x coordinate is 0.4427 meter, and the y coordinate is 0.0939 meter. Okay, so let's do this as an exercise, and we will do it together in the next slide. Okay, so first is